when you accidentally multiply matrices the wrong way, but nobody notices. Alright, so let's discuss what's going on right here. We are multiplying these two matrices and we get this for the result. What's wrong though? Because it looks like to me, we have 3 times 5, that is equal to 15. And then 6 times 4, that's certainly 24. And of course, 0 times 0 is equal to 0. And finally, 1 times 2 is equal to 2. So what's wrong with this? Well, if you check on Wolfram Alpha, it also gives us the correct answer, right? But unfortunately, this is not how we multiply matrices in general. Sometimes it works, but most of the time it doesn't. For example, if I give you another matrices, let's say 1, 2, 3, 4, and we multiply that with 5, 6, 7, 8. Can we really just do 1 times 5 and say the first entry here is 5, and the next 2 times 6 and say that's 12? Continue. 3 times 7, 21. Lastly, 4 times 8 being 32. No, this is not correct. Check out Wolfram Alpha real quick. So unfortunately, we do not have this kind of luck all the time, but it's okay because I will show you how to find more lucks. But before I do so, let's see how we can multiply this the correct way. So when we multiply two matrices, what we will have to do is the dot product of this row and this column for getting the first entry here. What I mean by that is the following. We take 1 times 5, and then we are going to add 2 times 7, and that's the dot product. And we continue to get this entry. We do 1 times 6 plus 2 times 8. That's 8. And continue. We do 3 times 5 plus 4 times 7. Finally, 3 times 6 plus 4 times 8. So as you can see, to multiply two matrices is quite complicated, and if you just work this out, we will end up with 5 plus 14 is 19, and then 6 plus 16 is 22, and this is 15 plus 28 is 43. Finally, 18 plus 32, we get 50, and this is the correct answer when we multiply these two matrices. Now, let's go ahead and see how we can find more lucks like this, because it's fun. We are going to start with two general matrices. Let's say we have A, B, C, D multiplying with E, F, G, H. And we will do this the right way first. So that is AE plus BG for the first entry. Continue, AF plus BH. And the next, CE plus DG. Finally, CF plus DH. Then, we are going to set this equal to when we multiply these two matrices the wrong way. That is entry by entry. So we are going to have AE, next just BF, and then continue CG, and then lastly, we have DH. So this is how we are going to force things to happen the way we want it to be. And in order for this matrix to be the same as this, we just have to set the entry is equal to the entry correspondingly. Alright, so we have these 4 equations with 8 unknowns. But it's not so bad. Firstly, though, you can see that AE and AE cancel. So for the first equation, this right here will tell us BG must be equal to 0. And we can do the same thing for the last one. DH also cancel, so this implies we must have CF is equal to 0. And for the first one, this right here implies either we get B equal to 0 or G equal to 0, or maybe both. And from here, this we will know C equal to 0 or F equal to 0 or both. So let's just focus on how the original post on Reddit get the matrices that in the post. So I'll just write this as the OP case, and then later I'll also show you guys another case just for extra fun. So in the original post, we know this and that entry are equal to 0. So that means C and G equal to 0, and we have those two conditions here. So we'll focus when G equal to 0 and also C equal to 0. So it's going to look like this. We have a 0 here for C, and then also 0 here for G. And then we just have to figure out what we want for the other entries. Okay, notice if G is equal to 0 right here, the first equation doesn't really tell us anything, right? Because in here, B can be anything, because anything times 0 is equal to 0. Likewise, because we have C equal to 0, the last equation wouldn't tell us anything. That means just F can be anything. Now we are going to focus on this too. With the same reason though, I will tell you that the third equation doesn't do us any good. Because when C equal to 0, this is just 0. When G is equal to 0, this equation is just 0, is equal to 0, so cannot do anything. So our last hope is to get the second equation. From AF plus BH is equal to BF. Let's focus on, depending on what you want to isolate, maybe the B or maybe the F. It's like up to you. Doesn't really matter. Let's focus on solving for F. All right. So I'm going to move this to the other side. That means we get BH is equal to BF minus AF, and then factor out the F. So we have BH equal to F times B minus A. So I can divide this on both sides. This tells us F is equal to BH on the top over B minus A. And now, notice we have A, B, H. They are free variables, meaning that you can pick whatever you want. And of course, do not pick A is equal to B, otherwise this formula is going to be destroyed dividing by 0, right? So let's see. In the original post, the first entry here was 3, so we pick 3 right here. Next, for B, it was 6. So this right here is 6, and this right here is also 6. And lastly, H is 2. So with all these choices, we see that F is going to be 6 times 2, which is 12, over 6. This is 6, this is not B. 6 minus 3, which is 3. So F will be equal to 4, and that's based on all these choices. So let's just go ahead and fill this in. 3 goes here, and then B is 6, and H is 2, which is right here. And with all that being done, we will have to put 4 for F. Now, notice we have D and E. What do we put with those two things though? I will tell you, you can put anything that you want for D and E in this particular case, because there's no condition anymore. And you can also have a look. Right here, D happens here, but that's multiplied with G, so D doesn't matter. Likewise, E happens right here, but that's multiplied with C, which is 0, so that doesn't contribute anything either. So you don't have to worry at all. And I really like the original post, because what the original post chose was, we have the 0 already, we have the 2 already, we have the 3, and then the 4, and then the 6. What are we missing? Of course, 1 and 5, right? That's perfect. So we have 1 right here. Let me just use a different color because it's meant to be free variable. I use green. 1 here, and then 5 here. So this is how the original post did it.